Okay, and the final reaction that we're going to look at for nucleophilic substitution is with ammonia. So we're going to take our halogenoalkane, react it with an amine. So there are two lots of amines in this equation, and we'll cover that in a second. And the product of that is going to be an amine with the R1, it's the same group attached, and then you're going to get this product, an R3X. So once again, we'll use bromoethane. We are going to take our amine, NR3. So the lone pair is on the nitrogen, that's where your electrons are coming from. A delta positive carbon, delta negative bromine. I'm going to draw an arrow from these electrons to the carbon, and then from this bond, which is going to break, and the electrons are going to go to the bromine. So that is going to leave us with this. And now, because the nitrogen has got four bonds, that's going to be positively charged. Okay, so that's got a formal charge on there. It's not a delta charge, it's a formal charge. And we're also going to be left with our bromine ion. Okay, so these are both neutral, and now we've got positive and negative, so they balance, so that's fine. So the second part of that, there's going to be another part to this equation, so I'm just going to copy this down here. So this is where our second amine comes into the equation. So this is a reversible reaction, this is an equilibrium. So this reaction is happening as is this one. And what's going to happen is we're going to take another, sorry, that should be a H, we used ammonia in this example. So NH3. Again, that's got a lone pair. This is now going to act as a base, and it's going to steal one of these hydrogen atoms, and then the electrons from this bond here are going to go to the nitrogen, and they're going to cancel that positive charge. And this is what we're going to be left with. So we've now got an amine. So we've started off with bromoethane, and we've now got ethyl amine. And we're also left with NH4Br. So the NH4 has got a positive charge on it, and the Br has got a minus charge on it. And that is called the ammonium ion. Okay. So the conditions for this, just like the last one, it's going to be warm. We need excess amine. Now this is because if this species here, our product, has a lone pair, so this could act as a nucleophile. This could take the place of this, and this could react with our starting material, which we don't want. So if you use excess amine, that's a way to overcome that. This is again going to be an ethanolic solution. It's not in water.